Welcome, data professionals. Today, we're exploring Snowflake Cortex Sentiment Analysis, a powerful, fully managed feature that allows you to automatically detect the tone of your text data directly using SQL. Let's get started. Let's begin by defining what sentiment analysis is within the Snowflake Data Cloud. In short, it is a specialized feature of Cortex AI that evaluates raw text to determine its tone. Snowflake actually gives us two ways to do this. First, there is the classic sentiment function. This is a simple, effective tool that takes a string of English text and returns a numeric score from -1 to +1. However, the recommended, modern approach is the AI sentiment function. This upgraded version doesn't just return a number, it returns a rich, structured JSON object that categorizes the tone into specific buckets like positive, negative, mixed, or neutral. Diving deeper, the true enterprise value here is security. Because these functions are powered by Snowflake's proprietary, fully managed large language models, your highly sensitive customer data never has to be sent to external third-party APIs. It is all processed natively and securely. Take a look at this high-level architectural flow. On the left, we start with your unstructured text, things like customer reviews, survey responses, or support chat logs. This data flows securely into the Snowflake Cortex engine. From there, you choose your path. You can route it through the classic sentiment function for a simple numeric score, or pass it through the modern AI sentiment function to get a detailed JSON categorization. Both paths seamlessly merge back into your standard data analytics pipelines, instantly turning messy text into actionable, structured data. Why should your organization care about implementing automated sentiment analysis? The primary driver is massive scale. Human beings cannot manually read and categorize millions of product reviews or support tickets every day. Sentiment analysis automates this entirely, operating at the speed of your Snowflake warehouse. Secondly, it provides actionability. It takes subjective, messy opinions and transforms them into hard, quantifiable metrics that executives can track on a dashboard. This unlocks powerful use cases like real-time social media monitoring, brand perception studies, and pinpointing friction in the customer journey. For a deep dive into performance, Snowflake's custom AI sentiment model is actually fine-tuned specifically for this task. In rigorous benchmark testing, it frequently outperforms massive, general-purpose LLMs like GPT-4 or Claude on strict sentiment extraction accuracy, giving you enterprise-grade reliability at a fraction of the cost. This mind map breaks down the core value propositions of Cortex sentiment analysis. At the center is our goal. Branching out, we see automation, which allows us to process millions of rows instantly without manual labor. Moving clockwise, we gain actionable metrics, fueling dashboards and KPI tracking. Then we have our primary use cases, tracking brand perception, triaging support, and analyzing product feedback. Finally, we achieve high accuracy because we are utilizing a highly specialized, custom LLM rather than relying on a generic, broad knowledge model. Let's get practical and look at exactly how to execute this. Using the modern AI sentiment function is as simple as writing a standard SQL select statement. You simply pass your text column into the function, select AI sentiment, review text from my table. That is it. No complex Python environments or API configurations are required. The output of this function is highly structured. Instead of plain text, it returns a JSON object. By default, this JSON object contains an array called categories. Inside that array, you will find a category named overall, paired with its calculated sentiment, for instance, positive or mixed. Diving deeper, because Snowflake natively treats this output as a variant data type, data engineers can easily extract the exact sentiment string using Snowflake's native JSON parsing capabilities, like dot notation, allowing for immediate aggregation and filtering in downstream views. This sequence diagram illustrates the simplicity of the execution flow. The data analyst starts the process by submitting a standard SQL query containing the AI sentiment function and a text string. The Snowflake SQL engine securely passes the string to the underlying AI sentiment model. The model evaluates the text, calculates the tone, and returns a perfectly formatted JSON object. This JSON showing an overall sentiment of positive is then seamlessly delivered back to the analyst's result set, ready for further analytical processing. Now for a massive deep dive into one of the most powerful capabilities of this function, aspect-based sentiment analysis, or ABSA. The reality of textual data is that it is often mixed. Think of a restaurant review where the customer says, "The pizza was divine, but it was way too expensive." A single, mixed score isn't very helpful for business operations. AI sentiment solves this. You can pass a second argument to the function, an array of specific aspects or entities you care about. By executing select AI sentiment, passing your text, and then an array like food quality, cost, and wait time, the model will return independent sentiment scores for each specific aspect within the exact same JSON response. For architectural constraints, please note that you can specify a maximum of 10 aspects per function call, and each aspect label must be 30 characters or less to ensure optimal model performance. Let's visualize aspect-based sentiment analysis. At the top, we have our raw, mixed review text. We feed this into the AI sentiment ABC engine, explicitly asking it to look for 3 specific aspects. The model expertly dissects the sentence. It routes to the left, identifying food quality as positive. It routes to the middle, identifying cost as negative. Crucially, it routes to the right for wait time, and since the review didn't mention time, it intelligently returns unknown rather than hallucinating an answer. All of this is packaged cleanly into your final JSON output. Another extraordinary feature of the AI sentiment model is its native multilingual capability. Global enterprises generate data in dozens of languages. Traditionally, data engineers would have to run a translation model first, and then run a sentiment model. This is costly, and more importantly, translating text often destroys cultural nuances, idioms, and local slang, heavily skewing your sentiment scores. Cortex AI sentiment natively understands English, French, German, Hindi, Italian, Spanish, and Portuguese. You simply pass the raw foreign text directly into the function. The LLM processes the sentiment natively in its original language context, preserving the true meaning. Even better, you can query Spanish text, but provide your aspect array in English. The model will understand the cross-lingual intent and return the JSON payload in English, making global analytics incredibly streamlined. This flow diagram highlights the elegance of native multilingual processing. On the left, we have reviews coming in simultaneously in Spanish, German, and Hindi. Instead of routing these through fragile, intermediate translation pipelines, they all feed directly into the universal AI sentiment model. The model comprehends each language's unique semantics natively and processes them. It then outputs a standardized English JSON payload for all of them. This unified stream of data flows perfectly into your global analytics dashboard, completely eliminating language barriers from your data engineering workflows. As senior data professionals, we must understand the governance and limitations of the tools we deploy. First, access control. The AI sentiment function is securely locked down by default. To use it, an administrator must explicitly grant your role the Snowflake.Cortex user database role. Next, we must respect the model's physical limits. The AI sentiment model has a strict context window of 2,048 tokens, which equates to roughly 1,600 words. If you pass a massive 50-page document into the function, it will fail. For long documents, you must chunk the text first. Regarding costs, this feature is built seamlessly using Snowflake compute credits, calculated based on the total number of tokens processed per call. Finally, data privacy is guaranteed. Because this is a Snowflake-managed model operating within your account boundary, your proprietary data is strictly protected and never used to train base models for other customers. This architecture diagram maps out the strict security and validation checks that occur during execution. A user query enters the system and immediately hits an RBC check. If the user lacks the Cortex user role, access is denied. If authorized, the system performs a token limit check. If the text exceeds the 2,048 token limit, the query fails or requires manual truncation. If it passes both the security and size validations, the engine executes the AI sentiment function. Finally, the system calculates the exact token usage to securely bill your account, ensuring predictable, governed AI operations. Let's apply this to a critical, real-world scenario: automated customer support triage. Imagine a massive global retailer receiving tens of thousands of support emails every day, spanning 5 different languages. If human agents read these chronologically, a furious customer threatening to cancel their contract might wait 24 hours for a reply. The architectural solution is to build a Snowflake dynamic table or a stream and task pipeline that ingests these emails. As soon as a record lands, the pipeline triggers the AI sentiment function, utilizing aspect-based extraction to track product quality and customer service. If the model flags the overall sentiment as negative and the customer service aspect as negative, that specific database row is instantly routed into a high-priority escalation queue. You have just used the data cloud to transform a reactive, manual backlog into a proactive, intelligent triage system. Let's trace the data pipeline for our automated triage system. On the far left, incoming support emails land continuously. A Snowflake stream captures these new inserts and triggers a scheduled task. This task executes our AI sentiment function across the new batch. The system then dynamically routes the records. Emails categorized as negative and urgent are pushed to the high-priority escalation table, feeding directly into a senior agent's dashboard for immediate action. Meanwhile, positive or neutral emails flow smoothly into the standard queue for normal processing. It is a highly efficient, AI-driven operational workflow. To wrap up our training, let's review a few senior-level best practices. First, think about composability. If your feedback contains sensitive data, chain the AI redact function before AI sentiment to securely strip out names and emails before evaluating the tone. Second, build resilient pipelines. Set your session parameters to prevent a single malformed text row from failing an entire overnight batch load. Finally, optimize your costs. Aspect-based sentiment analysis uses more tokens to generate a complex JSON schema, so only use ABC when you specifically need granular data. Otherwise, stick to the overall sentiment. Thank you for joining this deep dive. To truly master these AI capabilities and accelerate your career, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and comprehensive interview guides. Keep building. Our final diagram outlines the gold standard for an AI processing pipeline. We start with raw customer feedback. Before doing anything else, we route it through AI redact to strip out sensitive PI, ensuring absolute compliance. Then we move into AI sentiment analysis. Here, you must make an architectural decision based on cost and need. Do you need granular details? If yes, use the ABC arrays. If no, stick to the overall sentiment to save tokens. Following these steps leads directly to our final goal, an optimized, secure, and cost-effective production pipeline. See you next time at QuickTechie.